Let's start with a sort of very dry definition, and I hope I can, in the next like 20 minutes or so, share with you a little bit of the fascination I have for this topic for various reasons. So it's actually quite easily defined. It is the phenomenon that an individual has a secondary perception when a different sensory or cognitive pathway is stimulated, which is not directly related. And what's important is that this is happening involuntarily. So to give you an example, a very common one would be, for example, that for some people, letters and numbers have a color. So that is called grapheme color synaesthesia. So they assign a certain color to a specific letter, like A or whatever. And assign is not the correct word. They just have this impression immediately. So it's not the same as if I ask you, like I'm singing you a small tune, like dum da dum dum, and I ask you what does this tune make you feel, and you start to reflect. The sound's a little cheerful. I'm thinking of spring, maybe of green, of leaves, and then you start to arrive at a color perception when you hear this. No, it's essentially an instantaneous event, just as if you open your eyes, you see a red square, you don't have to decide that you see red, you just see red. And this involuntarily secondary perception upon having a primary stimulus, that's what calls synaesthesia. So this could be on the sort of same visual pathway, having colors which you assign to letters or letters to colors or whatever. But it can also be different ones. So for example, the auditory tactile synaesthesia is that people have a sensation on the skin when they hear certain sounds. So they have a very different kind of linking of perceptual levels. Okay, so why is this interesting? I mean, first of all, I would say it's interesting from a sort of general, more philosophical point of view, and I'll talk about this in the second part. But first, let me talk a little bit about neuroscience, because it's, I would say, quite fascinating that, as quite a lot of things in neuroscience, as of today, the neurological foundations of this phenomenon are not understood. There are a couple of theories which are all partially explaining this phenomenon, but also partially lacking explanation. And there are three dominant theories at the moment, and I'll introduce you to them, and highlight which part they sort of get right and which part is causing problem. So the first one is called cross-activation. And this is essentially a very simple model. It is the idea that certain parts of the brain which are responsible for processing these sensory inputs kind of start to communicate with this adjacent part. So for example, you have like this spot in the brain right here, and then it's somehow, with some mechanism, it kind of triggers the next part in the brain, and then you have this secondary sensation. This can explain certain types of synaesthesia quite well. So for example, the aforementioned grapheme color synaesthesia can be explained by that, because the brain region that gets activated during the perception of graphemes is quite close to the one that gets activated when we perceive colors. However, there are caveats to this. The first biggest weakness of that is that it gets very difficult to explain phenomena where you have synaesthesia between very distant brain regions. So for example, the also aforementioned auditory tactile synaesthesia, these are very different regions of the brain. When you get touched by something or someone versus when you hear something, these are very much far away from each other, and as far as we know, there is no communication between these brain regions. So there is a problem. The second problem, which is sort of a side note from my own interest in neuroscience and theory of mind, is that the concept of brain activation, and I hope that I don't piss off any neuroscientists now, but is a quite difficult one in the sense that it's often measured by activity of cells. So for example, fMRI studies employ the oxygen consumption of cells, which is a very logical assumption, but it's a quite strong assumption. And you could easily also have models of brain activity where you have cells that actually are less activated and sort of block a signal from proceeding, but can also have a kind of effect on how signals are processed and how signals are perceived in the end. So just by saying there is a high brain activity doesn't necessarily mean that this is the only region in the brain that's actually relevant. The other ones you would just not see. So it's just a slight side note, and this is heavily debated, I'm fully aware of that, but still just as a side note. The second theory is related to inhibition of feedback, or rather disinhibition of feedback. So what do I mean by that? So when we perceive a sensory stimulus, what's happening is that we get the primary sensory areas, so essentially the first part of the brain where the signal from the respective sense, like the nose or the eye, arrives in the brain, and then it gets further processed into the cerebral cortex. And then it can also travel back from the cerebral cortex to the primary sensory neuron and can then go in a different direction. Normally, this pathway is sort of inhibited so that you only get the forward but not the backward translation. And there are theories which suggest that it could be that this inhibition is sort of disinhibited in people with synesthesia. So essentially, you have the primary sensory input and then a back propagation from the cerebral cortex, and then from there it gets distributed somewhere else. This obviously can very well explain the synesthesia for distant brain regions. The problem there is that you can sort of simulate this kind of phenomenon quite easily with drugs. It has been shown, for example, if you take LSD, that this is exactly how this drug happens. This is not advertising LSD, but it seems to sort of lower this kind of inhibition management in the brain. Interesting enough, though, very few people report on synesthetic effects when taking these kind of psychedelic drugs. You have color impressions, but not necessarily connected to sort of another sensory input. So it seems like that this is also not the full story. And then there is a third dominant theory which is related to semantics, which is known as synaesthesia. So the idea here is that it's actually not really the brain directly, the physiological process that's affecting the perception of synesthesia, but actually it is the assignment of meaning to something, which then involuntarily triggers a secondary meaning. So what I mean by that, if I show you an apple, and this is a good segue into the philosophical part, you don't, like your perception will most likely not be, this is a round object, red, interesting, roughly the size of my fist. What round red objects that are roughly the size of my fist do I know? This might be an apple, right? No, you see, oh, apple, right? It's an instantaneous phenomenon that you perceive an object and assign a meaning to it. And the theory of this semantic theory of synesthesia says that what's happening is that we involuntarily attach meaning to sensory inputs, and this assignment of meaning can trigger, in people with synesthesia, other parts of the brain. This sounds like an interesting theory and has many followers. A problem with that is that there are a couple of more recent studies which tested this grapheme color synesthesia in people via peripheral vision experiments. What you do there is that you show the people a letter in the peripheral region of your vision. And what's happening is that you cannot see the letter. You can make this experiment yourself. You take a letter A or something and you put it here. You see that there's something, but you don't see what it is. And the interesting thing is that when these people are then asked, what color do you assign to letter A? And let's say it's yellow. And you show them the letter A, but they can't identify the letter A, they still report on a yellow color perception. So it seems like that this attachment of meaning in this case wasn't necessary to have the synesthetic effect, because they did never arrive at the point where they say, oh, this is A. So we're left with the classical situation that we have a couple of theories which are mutually exclusive and not fully explain the thing. Maybe it's a mixture. We don't know yet. So, yeah. There are obviously, I should say, many more theories, also combinations of these theories, and yeah, So this was a very quick sort of rundown, but these are the three dominant explanations for this phenomenon. So one thing that I wanted to talk about is sort of more the philosophical interpretation of what it means for our concept of mind and perception that synaesthesia exists. And for that, I think an easy question to ask would be, what is a little weird about synaesthesia? Like, why? Like, it's an effect. Like, whenever I talk about this to people that don't know this, are like, oh, it's a bit weird. So, what exactly do we find weird about this thing? And I think the impression is that it's a little odd for us to think that someone's perception is fundamentally different from our own perception, and not in a deficient way, but in an expanded way. You can very easily imagine how it must be to be blind by just closing your eyes. But you cannot really imagine to have an additional perception to something you are already used to. So there's a fundamental difference in how people with synaesthesia perceive the world than from people who don't have synaesthesia. And that is something, oh, okay. And that is something that I think we're not really, we're not really used to thinking like that. But the point I would like to make strong here is that really it's not weird at all. In fact, I would say it's actually the opposite. So you can never tell how someone else is experiencing a certain sensory stimulus. In fact, what I find really crazy is, why should it be? Right? We are different people with different brains, with different histories, and still we are remarkably good at agreeing on almost all our sensory inputs. Why? It's not a given at all. And the more you think about it, the weirder it becomes that we are so good at agreeing about an extra mental reality that we only perceive via our inputs, via our senses, and communicate about that, and be able to just completely, seems like, be not to run into any problems here. So this problem is heavily debated in philosophy. I would say it's among the top problems. It's similar to the $1 million problems in math, the millennia problem. If you solve this, then you get the Nobel Prize for philosophy if it would exist. And this is related to the discussion of what's called qualia. I would like to introduce this term just to be able to talk about it a bit. So qualia sounds a bit weird. English translation also is sometimes called raw feelings. And what this concept means is that there is a distinctly subjective, personal quality to having a perception. So if you're cold, you don't not only, oh, it's cold, it feels a certain way to be cold. It feels a certain way to see red. It feels a certain way to smell vegetables. You have a personal, subjective experience when having a perception. And this is known as a raw feeling or as qualia. And the question now is, how do these subjective parts of perception relate to reality? And I would say the most important theory for explaining this, at least in terms of being a natural scientist, and probably most of you unknowingly perhaps subscribe to the theory, is what's known as objective representationalism. This sounds complex, it's actually not. It essentially says that the sensory impressions, the perception we have, the personal experiences when having a perception of light, color, sound, taste, etc., that these are faithful representations of what is perceived. So you cannot perceive the extra mental reality directly. So, you don't perceive red light directly, you perceive it via your eyes, but your perception is faithfully representing this extra mental reality. And the idea now is, and I think that's why I'm saying that most natural scientists will subscribe to this theory, if you have an identical physical stimulus and identical bodily functions, then two people will have the same feeling, the same qualitative, personal, subjective experience when experiencing a certain sensory impression, such as red, such as sound, etc. You may now say, oh, what about color blindness? Well, there the bodily function is not the same, right? So I think this is something we quite by standard operate. Like if you do experiments, you say, okay, I'm having the same stimulus, I have multiple people, and all these multiple people will have like similar reaction to that stimulus, and then I draw conclusions about how things work. So this is what I would say what we mostly do when we do experiments in this space. The existence of synaesthesia causes a massive problem for this theory, as you may guess, because if people with synaesthesia exist, and this is obviously, as far as we know, the case, then it seems like that some people have very distinct personal, subjective experiences when perceiving a certain sensory stimulus, even though they have the same stimulus and as far as we know, the same sort of bodily layout. So one of the main discussions in representationalism is, at the moment still, if it needs to be adapted because synaesthesia exists, or if it still is able to explain it somehow. I guess the take-home message for us is here that the sort of naive assumption that there is some sort of reality that is probed by an experiment can be made, but that it's worth to always reflect about this, and not only since the measurement problem in quantum mechanics, it's also applicable to almost any other experiment we do. So I think what makes me fascinated about synaesthesia in a more broader context, I can best explain by sort of leaving you with a task. And this task would be to imagine to have another sense, which is very difficult if you try it. So let's say I have an extra sense and I could sense how, for example, Wahid is feeling right now. If he's like bored out of his mind or excited, or I don't know. But you find yourself often slipping into then using that sense in combination with another sense. So for example, I could maybe see an aura around a person which is maybe glowing yellow when they are happy and red when they are angry or something like that, but then you have just translated your extra sense to your eyes. So having an extra sense, really, that is completely detached from the senses we have right now is, I think, almost impossible. I didn't manage so far to imagine that. And what I find interesting is that we can quite easily imagine a merely quantitative expansion of our current senses. So for example, bees can see the ultraviolet, and we can see, well, for them the world will look a little different because they have just a wider spectrum of perception. So it's just a quantitative extension. And I think synaesthesia in some sense is right in the middle. You essentially combine your senses that you already have, but not just quantitatively extended, but qualitatively different. You would have a different kind of worldview if you had synaesthesia, because you would perceive the same sensory inputs in a very different way. And the question now is, why doesn't everybody have it? And I think it's just like a thought experiment to finish with. It might be, if you want to pull the evolutionary card, actually a disadvantage. If you imagine you are constantly overloaded with sensory inputs, like there have been reports about people with multiple synaesthesia, they have very easy task to conceptualize, for example, very complex mixtures of numbers and letters and things, because they essentially perceive where we just perceive like a huge bag of lines, and you have to like, okay, this is a 5, 4, what is A, L, whatever. They see all these things in different colors and immediately are able to separate them. But imagine when you walk through the world and you have a constant overload of sensory input. It might be that it's actually an effect of our continuing specialization into, being better at rationalizing and abstracting our world, and being less reliant on our senses and more on our interpretation of the senses. Maybe. It seems like children sometimes have synaesthesia and lose it as they age, but rarely. There are older reports about people having more synesthetic experiences, but they have to be taken with a grain of salt because they're often not with the same scientific standards as we would nowadays. So that is something that is just maybe something to speculate about. What's very interesting is that there are certain genetic determinants. So it often runs in families where the daughter, the mother, all have some sort of synaesthesia. And it's very often also found with artists, musicians. The question obviously is a hen and egg problem. Do you become an artist because you have such a rich experience of the world, or is it because you're an artist you're more likely to have synaesthesia? I don't know. Okay, but with this I would like to conclude. I hope I could share with you some of the fascination I have for this topic. And if you want to continue the discussion, just let me know. I have tons of materials about this, and I would love to, spread it further. And I think it was hopefully evident how quickly you come from the seemingly simple phenomenon to a wide range of quite fascinating problems in neuroscience and philosophy. Thank you very much.